So you're given a waveform that looks like this. And the question is, this is a voltage. The question is, find the RMS. So my very first suggestion is before you do anything else, to give a rough guess. You're going to find that your intuition is really good. It's usually within about 20 or 30%. It helps to know if you're doing the problem right. So let me start off with Casey, you're the one who asked the question. If that's a voltage, and if it's being fed into a resistor, what would you guess the average DC equivalent would be that would cause that resistor to dissipate the same amount of power? What would you guess?
2.
You'd guess around 2. Yeah, that would be my guess. My guess would be VRMS. My guess is about 2 volts. And it wouldn't surprise me if it wasn't exactly 2. I know the average of V of T is 2, but that's not the average power that it represents, because as the voltage goes up, the power goes up as the square of the voltage. So if anything, I would guess it's a little higher than 2, but 2 is not a bad guess. So now let's figure it out. Let's figure it out exactly. So the first thing is we have to figure out what V of T is, right? We can see it's going to look something like this: 2 plus something times cosine of something T plus something. Does everybody agree with that? Thumbs up? Yeah. All right. So Caleb, fill in one of those somethings for me. Let's fill in the first something, this cosine thing.
2.
2. And that makes sense because the cosine function goes between +1 and -1. So when this whole cosine is +1, we get 2 plus 2 is 4. And when this whole cosine thing is -1, we get 2 minus 2 is 0. So I'm going to give a wild guess with time. There's ways to do this more effectively, but I'm going to give a wild guess with time. What if we just put down 1? If we have omega equals 1, then can anyone tell me what its frequency is? Brian?
Isn't frequency equal to 1 over T?
1 over T, but what is it? What is frequency as a function of omega? You're right, frequency is 1 over T, and we're getting there. Our overall goal is to find out what that T is. So to do that, I have to find out what its F is. To do that, I have to find its omega, and I was going to do it backwards, but let's just solve it forwards. Brian, tell me what the time period should be.
Pi?
Should be pi. So if the time period is pi, then I want you to tell me what the frequency is.
1 over pi.
1 over pi. And then what's the relationship between omega and F?
Would omega still be 1? I would assume.
Well, I start off by assuming omega is 1, but no, now I want you to tell me the mathematical relationship that's always true between omega and F. Always true. All right. It's 2 pi F. That's a relationship between frequency in hertz and frequency in radians per second. So since we know that F is 1 over pi, that means this is 2 pi times 1 over pi, and that means it's 2. So that says that this is 2. And now we only have to figure out the phase. Tim, Mackie, what's the phase? Does this look like a cosine phase? Does a cosine start off low and go high, or does a cosine start off high and go low? What does a cosine do?
Cosine starts at 1.
Cosine starts off at 1 and goes down. So this
looks like a sine.
So it looks like not a sine. A sine is 90 degrees out of phase. So a sine starts out at 0 and goes up. Or if it's 180 degrees out of phase, a sine does that. So this is what a cosine does. This is what minus cosine does. That's 180 degrees out of phase. This is what a sine does, and this is what a minus sine does. It's 180 degrees out of phase. So because this thing starts low, it looks like this guy. So we've got a minus 1, we've got a 180 degrees out of phase, plus or minus, it doesn't matter. It's the same thing. So that tells us what our voltage waveform is. It's equal to 2 plus 2 cosine of 2t plus 180 degrees. And we could write that a little bit even more simply by just saying this. No difference between cosine plus 180 and just negative cosine. Same thing. Any questions on that?
Wait,
Cool.
where does 180 go?
So you'll remember from your high school trig that cosine of x plus 180 is the same thing as minus cosine of x. Same thing as sine of x plus 180 is the same thing as minus sine of x. You can
All right.
see why, because if you graph, let's just do cosine for a second. If you graph this thing that goes on forever, if you add, if you start off at 180 degrees out of phase here, this waveform just looks like the negative of this waveform. You can always turn yourself 180 degrees around and you're the negative of where you were. So this is true for any trig function. The tangent of, you can always add 180 degrees to anything and it just forms your negative. So now that you've got this, now we're going to find out what your V RMS squared is, and it's equal to the square root of the square root of the mean, which is the integral of 1 over t times the integral of your square of this. And we're going to square 2 minus 2 cosine of 2t. And it's all just algebra. I think what I would do, just so I'm not always writing these square root signs, is I would square both sides temporarily as I do this integral. I would cross multiply this, so I get 4, let's see, minus 8 cosine of 2t plus 4 cosine squared of 2t dt. All I did was I squared both sides and then I multiplied this thing out. And now it's just a problem in Calc 2, straight from Calc 2. A fast way to do this is to pull this guy, simplify this, realize there's a DC term and then there's a non-DC term. That would be your next step. I'll do one more step on this just so you see the whole thing. The DC term in this is a 2. So that 2 adds to the 4 and we get 6. And then the non-DC term is the doubles that frequency. And while you can do the trig to do the whole thing, I want you to recognize that when we're integrating this part, this cosine of 2t, this, because it's oscillating at twice this time period, what that's saying is we've got this cosine wave, and I don't even care about the phase for a second, but we're going to integrate it over twice its time period. So just by inspection, you can see you don't have to do all this using the long trigonometric rules of Calc 2. You can just simply, if you understand the visual part of it, you can see that there's 1, 2, 3, 4 quarter cycles up here. There's 4 quarter cycles down here. So there's as much area on the top as on the bottom. And so this will integrate to 0. Same reason this will integrate to 0. This is even more. This is 4 periods of it that you're integrating over. And so your whole thing is just going to be left with just the area underneath 6, which between 0 and t, ORT, we said is going to be equal to pi. So that's going to give us a total of 6 pi area. And the 1 over pi's cancel, and we just get 6. And so therefore, V RMS is equal to the square root of 6, which is, if you work it out, about 2.45, and the units are in RMS units. So that's our answer. Compare that with our guess up here, and we're actually pretty close with our guess. Any questions about that?